Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfarhana Sofwa Binti Muhammad Rosli and my matrix number is 2016447512 and my supervisor name is ENCIK Muhammad AZHAR bin ZULKEFLE. I'm going to present a review on the potential of activated carbon from bamboo as an ethylene gas absorber. Activated carbon is an adsorbent commonly used in manufacturing process where it was a better catalyst support system and adsorbent process where various analysis of carbon material in findings the fundamental principle of carbon in its role as a catalyst. Activated carbon also is selected because of its excellent high variance surface properties, its benefit for example hydrophobic design and the comparatively low cost of production. It is also stated that activated carbon is a multifunctional adsorption properties. It is capable of extracting a wide variety of substance, which is as an interesting alternative choice. In problem statement, at retail and wholesale market, there is no adequate means of post-harvest handling of fruits and vegetables that leads to the resulting in low market quality of the fruit and vegetable themselves. This is due to the softening, which it is an important factor in the loss of production after fruit harvesting, which due to the cell wall degradation by cell wall associated hydrolysis enzyme activities, thus increasing market demand in the purchase of fresh goods with a longer shelf life and preserved consistency. For objective, the first one is to study the potential of activated carbon made from bamboo to be used as a support for cobalt oxide catalyst. Second key for objective is to study the use of cobalt oxide impregnated carbon as potentially efficient material for ethylene removal. And third key is to compare the absorption efficiency of cobalt oxide impregnated carbon as a potentially efficient material for ethylene removal under 4 parameters: pH, contact time, adsorbent dosage, and initial concentration. The significance of study, ethylene is naturally derived from climatic fruits such as banana, papaya and pear that can facilitate the process of ripening more quickly. It is important to preserve the atmosphere of the product packaging at a very low concentration of ethylene, where the removal of ethylene from the storage environment was important for successful long-distance transport and subsequent storage to suppress its undesirable impact. For the characterization of bamboo activated carbon is a porosity enclosed by a carbon atom which is black and non-toxic, rigid, amorphous microcrystalline adsorbent. Bamboo is responsible for more than 60% of cellulose, where it mainly consists of carbon as significant element, and approximately 40 to 50% of the dry substance in bamboo is alpha cellulose. Thus, it indicates that bamboo has high carbon content. A relatively porosity indicator in an activated carbon sample is the iodine amount, where various activation temperature will impact the activation time of the iodine number. The best condition for producing activated carbon from bamboo were at activation temperature at 100 degrees Celsius and activation time 120 minutes. That results in bamboo activated carbon with the highest iodine number. Thus, the optimum condition resulted in bamboo activated carbon with the highest iodine number indicates that the development of pore of the activated carbon, which with an iodine amount between 600 and 1450 mg per gram, that came from the finding of Mahaneb SMR and Cheng et al. For physical properties of bamboo activated carbon, when there is an increase in activation temperature measured, BAT surface area will increase and indicates the development of pore. So, as you can see from the table, all the reference and of the previous finding on the results shows that high in BAT surface area from the surface characterization. As for the ash content, it must be lower, and for the carbon content must be high. That will indicate the bamboo was an excellent raw material of activated carbon. From the finding for both studies, which are by Mahanim SMR et al. 2011 and Huosi et al. 2020, shows that low in ash content, which is 7.22% and 4.44%, while carbon content for both were high, which are 69.85% and 46.18%. Thus, this similar trend was reported by AZHAR in 2005, that in the preparation of activated carbon from biomass, where the carbon content was higher than 60% and other must be as high as 90%. Other than that, it is owing to its high carbon content and low ash content, so the processing of value-added activated carbon is promising path forward. For the effect of pressure, absorbent dosage and contact time, it is known that ethylene uptake from the test performance of cobalt oxide impregnated carbon material for ethylene increase with increasing pressure, where a significant amount of ethylene is absorbed up to 40 kilopascal pressure. Ethylene removal also are best results when activated carbon were impregnated with a catalyst rather than activated carbon itself. That depends on the mass and type of activated carbon. Ethylene was absorbed quickly from the bark for the effect of time, and the rate of absorption becomes slower after a certain time. For the preservation time, without absorbent, the storage can only last 3 days, while longer preservation time were longer when higher mass absorbent provides. For the conclusion, the characterization of activated carbon from bamboo with extraordinary properties such as high conductivity, large surface area, and absorption property. Activated carbon from bamboo shows a promising function when impregnated with a catalyst rather than the activated carbon itself, where in this case cobalt oxide is drawn by its deep adsorption association with organic matter dependent on its adsorption and release functionality. Thus, the effectiveness of cobalt oxide impregnated carbon in a storage device as an ethylene scavenger, which will lengthen the fluid storage life dependent on its adsorption and release functionality.